In this video, I'm going to show you how to run my MPMD Endstop Calibration M666/M665 script from a Windows executable file. My instructions on GitHub are already pretty detailed and includes information about running this over Octopi or Mac as well. The main purpose of this video is to show you how easy it is to run the program. Yes, the word script is scary. Yes, the instructions have blown up into being quite a large wall of text. However, most of that text is for troubleshooting help, as well as reminding people about all the prerequisite hardware upgrades and tuning steps that come before this in the calibration roadmap. One special note, I think a lot of people see the carbon paper dimensional accuracy test step coming before the script and they run away. You do not have to run the carbon paper calibration if you're already okay with the dimensional accuracy on your machine. However, if you do run the carbon paper step, then that must come before this Endstop calibration script. So if you're wondering what Endstop calibration script means, M666 is basically the software way of adjusting the home sensors up and down so that they can all be in line with each other. And because it's really hard to get that set correctly just with a screwdriver. Then M665 is mainly used for dimensional accuracy, but the two things interact with each other, and that's why you have the script adjusting both values. There's a magic ratio that Dennis Brown found where you could adjust the end stops without messing with your dimensional accuracy. So the first hurdle that trips a lot of people up is you need to be able to connect over USB or Virtual COM Port for this calibration. See the video description for links on how to do that. And the second hurdle is do not skip any of the critical steps that come before this. Improved bed clips, belt tuning, part lubrication, bed surface upgrade because the stock sticker is terrible, maybe shimming the bed, and maybe other things as well. It's in the calibration roadmap that I'll link everywhere, whatever. And next, you probably see this before and after image, and what this is showing is, yes, the person who gave me this image adjusted the bed clips. They installed a glass bed on top of a thermal pad without any crappy glass clips interfering with anything, and it worked out. And before I jump right into the steps, I want to point at this big bold text at the top. It says, "There is a comprehensive troubleshooting guide near the bottom of this post. I will not help you at all unless you have gone through that section and provided all of the requested information in the troubleshooting form." So let's scroll down there right quick and see what that is. Troubleshooting form / questionnaire. You see there's quite a lot of questions, some of them with links because they're loaded questions. I'm not going to read all these out loud. I just want to say I'm not trying to scare you away from asking questions. I feel like I'm pretty helpful, and so are other people in the group, and I'm not trying to insult your intelligence. However, if you need to ask a question about this script, then obviously you need our help, and we need these questions answered to be able to help you, because I'm not putting these questions here for just no reason whatsoever. Each of them serve a very good purpose. Yes, they matter. Yes, that matters. I'm not just blowing hot air when I say the bed clips are 100% necessary. I know that doesn't stop people from trying it anyways, but if you ask for help, I am going to demand this and then just stick my hands in my pockets until you at least try to answer it. If you can't answer it, just say, "I don't understand," next to the question, and I'll help you understand it. So let's scroll up and go to the instructions. Power cycle your printer to clear out any temporary settings. I've already done that. Make sure the nozzle is clean and then turn the nozzle heat off. I've already done that. Go ahead and preheat your bed to the desired temperature, and I'm going to do that now. I'm preheating this bed to 45 because it's on stock firmware with a stock power supply. That's about all that it can handle. And I need to spread this out. If you're currently connected to the printer via Octoprint, Pronterface, Repetier, Cura, Simply 3D, or some other service, click the disconnect button now. So let's open up Pronterface, and yeah, I'm not connected, so it should be okay there. Then Step 5, run the Python script with all the appropriate inputs set. So, instead of reading through this, I'll just point out I have a couple of examples for stock firmware you can copy and paste if you're doing the Python version, but I have a batch file. That's how we're going to do it on this one. So actually what I need to do that I hadn't done yet, I need to scroll back up here to the top, click this clone or download button, click download zip, and it's downloading down here. Let's go back to the instructions while I'm downloading that. So a few notes here. The script runs differently depending on whether you have stock or Marlin4MPMD firmware. It runs differently depending on what stepper drivers you have on the main board, and it runs differently depending on any tower rotation settings you might have stored into the firmware. So for stock firmware, you're just going to use 0 for the firmware flag and 0 for the tower flag, because it doesn't matter if you rotate your towers with the wires. What matters is if you rotate your towers using the special options in Marlin4MPMD, which if you have that you should know, and I provide the inputs for all of these. So it looks like my download's finished. Well, actually I already had one downloaded, I didn't have to pause there. So I'm going to pretend that I don't have 7-zip installed and instead just right click, drag, and click extract, and extract. Done. And now I want to open this folder, and what I find is this right here that's labeled Windows batch file. And I want to right click that, and I want to click edit. Wow, Windows Defender's not letting me help. Run anyways. Okay, and let me see if I can zoom in here. Well, let's Control plus it. Alright. So, replace these inputs with those from your machine/setup. Do not add any spaces or quotes. Enter your COM port exactly as it appears in Pronterface or whatever you're using. Right now this is set to COM3, but that's not what my printer's set as. What it is, when I connected earlier and I was able to actually send commands, see if I connect here on Pronterface, it's now online if I click. So I'm connected on Pronterface, and if I send G28 home, which G28, send. There, my printer moved, so I'm definitely on COM 100. So now I need to click disconnect. Let's minimize that now. So I need to update this to COM 100. Preheat the bed before running the script. Already done that. Set bed temp. I'm going to change this number to 45 because that's what I'm doing here. Fill in these M665 RNL values with your results from the carbon paper step or whatever you like to use, because these are your starting values. They will change by the end of the script, but these are also inputs to the script. I'm just going to leave these as default because this model of printer does better with these Dennis Brown values that he calibrated before, so not worried about that. Firmware versions, less than equal to 41, use 57.14. I need to update this comment because 45 is a little weird, but for firmware versions 43 or 44, use 114.28. This one's on version 44, so I'm going to copy this. I mentioned version 45 being weird, and that's just because people flash firmware 45 just because it's the highest number, but it usually defaults to the 57 number. But if you've made it this far in the steps, surely you know what your steps per millimeter are. If you need help, just ask me and I'll try to help you. If you're using Marlin, set this to 1. I'm not using Marlin, I am on stock firmware, so this is 0. If you're using Marlin 1.3.3, also set this to 1. I am not, so I'm setting it to 0. However, once again, if you did some extra things to rotate your towers in Marlin, or if you're on an older version of Marlin, you need to go back and read the instructions on how to set this tower flag properly. But if it's stock everything, 0, 0's just fine. And now that I'm done with that, I want to come up here, click Save, and I want to close this. And now I'm ready to run the script. I just right click, run as administrator, yes, setting the bed temperature. Now one note here, I am connected over the built-in Wi-Fi to calibrate this machine. I just recorded another video on how to do that. What I found is that while yes it does work, it also runs painfully slow. So there are better ways to do this. But anyways, I'm just going to leave this running, and I'm going to go talk about the next steps now. So, actually, I haven't downloaded Dennis's spreadsheet yet, so I'm going to click Make a Copy. You don't have to even open Dennis's spreadsheet here because this is just for debugging purposes if you want to. So there, I finished one pass. If I was running this on Octopi, I'd be running a lot quicker. And I have this Marlin only step. If you're on Marlin, you need to also run G29 again after this script's done, and then save anything with M500 because of the way Marlin saves the bed meshes. You have to update that bed mesh after you update other calibration values, but on stock firmware we're going to be doing everything in start G-code, and I'll handle that later. But for now I'm going to get ready a bed leveling test print in Cura. So let's see if I can get this to look right. I'm going to open up a file that I'll put a link to in the description. This Circles 110. If you notice, it's a little too big, so first let's change my profile. Let's change my profile to the MPMD default. And now, I haven't used this version of Cura a long time for a while, but I'm going to change my build plate adhesion to none, because this is a bed leveling test. I don't need any build plate adhesion. And now I need to rescale this so it actually fit. I don't know, I guess maybe there's some built-in tolerances here, but I found that I had to change this test to 108 millimeters to get it to load in Cura. Maybe there's some 1 or 2 millimeter error catching or something in the profile that doesn't let you go out to the very edge but could be removed. Who knows? And next thing I'm going to do is I'm going to mess with some sorts of parameters that can help you sort of hack your way into a first layer whether you've done this calibration or not. So I'm going to click on Configure Settings, Visibility, and I want to look at Initial Layer Height. I also want to look at Initial Layer Flow. And I also want to look at the initial layer speed. Okay, where's that at? Initial layer speed. There we are. So close. And what I'm going to do is first I'm going to change this initial layer initial layer height from 0.21 up to 0.28 because I am using the 0.4 millimeter nozzle that comes with the machine. And if you're using a smaller nozzle, you don't want your initial layer height to exceed about 75% of whatever your nozzle diameter is. But doing this helps you get away with some extra. This helps you get away with some things. So where's my initial layer flow? Here we are under Material, Initial Layer Flow. It's already set to 105% by default, so I'm not going to mess with that anymore. But this is another number you can crank up to basically help extrude more filament on the first layer to give yourself more room to get the stuff to stick. Now next we're going to go to speed, initial layer speed. I'm going to crank this all. If you really want to try hard, you can go all the way down to 5 millimeters per second on your initial layer speed. And you know, that does pretty good actually. That's as low as I would go. I wouldn't go any lower than that, but it's fine. And now I want to go back and I want to double check this. So I've scaled this down, and since this is a bed leveling test, first I want to uncheck uniform scaling. This Z height is set above 1 millimeter. That's just a waste of filament. All I want to do is test the bed leveling, and I want to be able to see if it's thinner on some parts than the others. So I'm going to set Z equal to my initial layer height of 0.28. But now I'm going to go into my next sort of first layer adhesion thing. I'm going to open up settings, manage printers, Monoprice Mini Delta, machine settings. I have not messed with any of this stuff yet, but I'm going to go down to the line that starts with G29. So what I'm going to do on the G29 line, I'm going to go ahead and change the pattern to P5, because that's what I'm going to need after the script's done running. And then I want to adjust my Z offset. And I'm just going to check how my script's doing. Script's doing fine. It's lowering the error. By default it's set to 0.28, which is good for a lot of people. But if you're doing the initial layer height hack, you can sort of cheat by lowering this down. I don't remember what I lowered it down to when I did the bed leveling test, but I want to say it was something low like 0.28, because since I was printing at a 0.28 millimeter layer height, I'm okay with smushing the rest of that down into the plate to get some good adhesion. If you care a whole lot about your Z dimensional accuracy, maybe you don't want to do that so much. Maybe you'd rather print on a raft and print on top of that to get better Z accuracy. Maybe you'd rather use some hairspray or some painter's tape so that you can use a more reasonable first layer Z offset. But for me, I'm mainly printing D&D figures and stuff like that, so I don't care. And so, let's see, the script is complete. Okay, so now that the script is complete, I'm just going to go by memory for the rest of these steps. This is Brian's default G code, so I created a new user account, so it looks like I haven't messed with this ever before. So first, I'm going to choose the correct M92 line based on my stepper drivers. And so for me, that's 114.28. Now, a lot of people might be like, why are you putting these in your start G code instead of saving them to EEPROM? Well, one thing is, this M665R value does not save properly to EEPROM on the stock firmware. Second thing is, if you have to watch a video to figure this step out, you're probably new to this, and it'll just be easier for you to put it in your start G code and easy for people to help you if you can just copy paste your start G code instead of copying paste your M503 output. So next thing, I have my M666 line, so I'm just going to go down here to this script, and I'm going to actually copy these two lines. You know what, I can't remember this stuff. Yeah, I think batch files, if you just highlight it, it copies it for you. So I'm actually going to completely delete these two lines. And so delete the two existing lines in there. I'm going to paste these two. Now I have my new M66 and my new M665 lines straight from the calibration script. Now next to my M665 line, I'm going to put a space bar and put a S120. That's your segments per second. It helps your printer. It's sort of the magic number where your printer can process things fast enough and not stutter. And so I think that's all the required changes. I've got M92, M66, M665, and I've already messed with my G29 line. Yes, P5 is important. It's better than P6 after calibration, because P5, even though it has fewer points, it goes out farther towards the edge of the build plate. And now I accidentally clicked it earlier, so maybe you already got a spoiler, but here's a result of my calibration test and doing the things that I showed you in this video. As I already did it before, I posted this budget build on the Facebook group where it cost me a grand total of $10. The cheap hobby mirror here I got from Hobby Lobby for like a 2-pack for $3, and then these binder bed clips, the hardware cost about $6 shipping included, and everything else was 3D printable. I just followed the calibration guides and calibrated my machine and did some hacky things in the start G code, and this is my first layer. So there you have it.